All righty, it's 10 a.m. Good morning, everyone, and welcome to another long coffee break. Thank you for joining us. I'm your host, Devin Gash. For those of you who do not know me, I've been with Long for about 10 years now, and I currently serve the role as project manager in our Northern Colorado territory, or Fort Collins. Today, my co-host is Jason Hornsby. He is the HVAC channel manager for our friends at Macro Air out of San Bernardino, California. And today we're going to talk a little bit about HVLS fans. For those of you who do not know what HVLS means, stands for high volume, low speed. With that being said, I'm going to turn this over to Jason. Jason, thank you for joining us today.
Thank you, Devin. It's great to be here. Glad to be part of Coffee Break and proud to be partners with Long, curing the planet one fan at a time. Again, I'm Jason Hornsby with Macro Air. We're the original inventors of the HVLS fan. I've been with Macro Air for 6 years. I've been in the HVLS industry for right at 13 years and in the HVAC industry for right at 28 years. We're going to share today on placement, places to put the fans, where and why. We're going to share some of the tools that's available to you as reps, contractors, and designers, be it an engineer or architect. We're going to go through our different control options, and we're also going to talk about some of the mounting requirements and clearance recommendations. Before we get started on that, I want to share a story on how HVLS fans became about. Our original invention, our owner was given a task by the University of California, Riverside, to come up with a better solution of cooling dairy cattle rather than the high-speed fans that you see on the outer wall in this barn. If any of you have ever stood in front of these high-speed fans, you know how great they are. They'll sit there and blister you. It's the exact opposite of an HVLS fan. It's actually low volume at a very high speed, so it's uncomfortable. You got to get right up on it to feel the airflow. They're loud, they're obtrusive, they're just invasive and not very comfortable. So our owner inventor invented the first HVLS fan. We ran them over the dairy cattle. Of course, it's a large column of air. It pushes down, it covers the entire stall area, the entire cow. So the cows are very comfortable. A lot of air at a low comfortable speed. You know, all these fans are variable speed, so you can get the velocity and the air movement right where you want it, so it is comfortable. And of course, the cows enjoyed it. After the fans were put in, the study was conducted, and the cows under the fan produced 15 to 20% more milk under the HVLS fans rather than the other cows under the high-speed fans. And then next we tested humans, and we even got more milk out of humans. That was a joke. Sorry, we don't test humans. But anyway, what we were after is productivity. Of course, everybody feels better when you're comfortable, and you have a higher productive rate when you are comfortable. So this relates to the next segment, which is where and why. So
yes. Thank you for that introduction, Jason. Yes, briefly explain where and why we use HVLS fans.
Surely. So I've got some applications listed here below, and of course we've got some pictures, but one of the most common places in the where we have these fans are warehouses, distribution, and manufacturing facilities. Of course, the number one reason these fans are in these buildings is most of these large spaces do not have air conditioning. So when the HVLS fans are installed, everybody feels great. You feel cooler when you have this air moving across your body. You're going to feel anywhere from 8 to 15 degrees cooler. So you get a higher productive rate. Your employees are more comfortable. It just creates a better space, and you're de-stratifying this space. A lot of people, you know, you've got these hot pockets that just hang up by the ceiling, and they're there all day just beating down on your workers. Well, typically what people do when you get in the warehouse, you cut these fans on early in the morning, and you never let those heat barriers build up. So you're 100% de-stratifying, keeping an even temperature, ceiling, floor, wall to wall. So of course your return on investment for the end user is worker productivity. You get higher outputs on that. We see these large warehouses, what they try to do is they have pedestal fans or these barrel fans all over the floor. I mean, you'll go in some of these places and they'll have 80 to 100 to 200 fans. Everyone has their personal fan. They're dragging them around to their workspaces. This wastes time. There's extension cords all over the floor. So it's a tripping hazard. It's just not very efficient way to cool a warehouse. These small fans really, the electricity it takes to run them is very inefficient versus one HVLS fan. One HVLS fan can take up the place of 20 to 30 of these smaller fans and sometimes even more. And they're about as efficient as one of these fans. So the HVLS fan, of course, is up high, it's out the way, super efficient at 483 phase. They're pulling like 3 amps. So super efficient there. The other benefits is you lower your humidity and your moisture barrier. A lot of these places, sometimes in the fall and spring, they run into what we call sweating slab syndrome. So when you have these cool nights and as the day starts heating up, and if there's any moisture in the air, I mean, these slabs just sweat. So you're talking about a very unsafe workspace. So we've installed HVLS fans and we help combat that. The next segment here under warehousing and manufacturing is agriculture, very popular in the ag industry and the equine industry. Of course, we're keeping animals cool. They're happier, they have more energy, and there's other benefits as well. Of course, they get people in the barns and the stalls and arenas. Of course, we're keeping them comfortable as well. But on top of that, we help with the flies. The flies just tend to stay away from the air. You get a better air quality, and you get rid of this, what we call stale air. There's particles in the air that give the animals respiratory infection. So when you get that stale air out of there and you're constantly moving the air, it definitely helps with that. Moving on down to aviation and auto service shops. Just about every auto service shop and aviation hangars, they want these fans, they have these fans. The mechanics love it. Just imagine them once again trying to drag around a pedestal fan with extension cords. They're trying to blow it where they're working. They move 2 foot to the left, they're out of the airstream. So the HVLS fans put air everywhere. These guys are under the airplane, in the engine hatch, they're in the airplane, they're in these cars with the hoods popped open, and one guy told me, he's like, you can't hide from the air. If I open both doors, even if I'm in the car, the air's coming in and out the car. I work on the engine. It helps dissipate some of the heat, and you can be under the car and it's just the air just goes everywhere. So really big benefit for those applications. Sporting facilities, of course, everybody's going to benefit, as well as the people playing the sports, the people in the stands. You've got athletes sweating, you've got people spilling water bottles and things like that. So keep the floor dry, keep everyone comfortable as well. Restaurants and bars, these fans are just cool. They're cool in 2 ways. Of course, they help cool the patrons, but they just look cool. So we create a curb appeal. We're seeing a lot of restaurants and bars and breweries. They're putting them in their tasting rooms, their outdoor areas. Patrons stay longer, they buy more product, and it's just a cool place to be. It just sets the atmosphere. And lastly, residential, we have all kind of different fan models, but we do have a fan that people just really dig in the residential market. They're building these elaborate outdoor kitchens, and the fan just kind of sets the space. And what I like to share is I've had a lot of homeowners, they said the key word with these fans is a game changer. When it's hot outside, everybody tends to go inside. If it's not comfortable, they're going to go find where it's comfortable. And these people just stay under these fans, and then they can enjoy these outdoor spaces and gatherings they have at their house. So
thank you for that, Jason. Now, in some cases, designing for the use of HVLS fans, some of our owners and design engineers would like to see a visual simulation of how the air is distributed in the space. What does this look like, and how is it done on your end?
Yeah, so before we get into that, I'd like to just show this slide real quick. This is a study done by NASA, and this is a no-brainer, but it's good to see, and it's really cool to see this. As you can see on the left side of this chart, as the effective temperature rises, the loss in output on your workers and loss in accuracy. And you can see as we reach 100 degrees, I mean, we really get a big loss, 62% loss in output, and it's unmeasurable, the loss in accuracy. And real quick, you know, we talked about these warehouses not having conditioned air. Some warehousing, these people are putting conditioning in these warehouses. And when energy is present, you know, typically you can raise your set points anywhere from 5 to 8 degrees and save a lot of energy. Typically, a typical return on investment for the end user is, you know, 2 to 3 years, sometimes more, sometimes less. And real quick, I know we're talking to a lot of guys in Colorado. A lot of these warehouses may not have air conditioning, but they have heat. So these fans are reversible. All of our fans are reversible, so you can turn them in reverse and bring that heat down in the winter as you cut the heaters on, and it really it introduces the heat, you know, push it up to the ceiling, down the walls, and it introduces it gently where you don't create a wind chill factor as well. And we can move on to the air vis. Just wanted to show that real quick. This is a recap, of course, real quick, why and where. Go back one. Yeah, so this is just a recap. Improve employee comfort, improve productivity, reduce HVAC expenses. And here's a chart where you can see as the guy, he's going to start feeling cooler as the air goes. And as you see how the airflow comes off the fan, comes down across the floor, goes from a vertical airflow to a horizontal. So moving on to the air vis. Here's a simulation that we did for one customer, and we can do this for anybody who really wants to see improve. And the reason why we do this is we found that some of our competitors were over fanning or under fanning a space. So we create a 3D image, and if we have the length, width, and height, we can do this. This is called a computational fluid dynamic model. Here's the video. On the next slide, we will show a side profile velocity. So we're trying to accomplish a certain airspeed based on ASHRAE 55 standards, and we have an overhead velocity chart and profile as well. So this is how we know we're putting the right fan in the right place, and we know we're getting full coverage.
Thanks, Jason. So my understanding is that all macro air fans come standard with a digital remote assembly on, off, high, low. What other control options do you offer, and do you have a solution for tying into a fire alarm?
Yes, so all of our fans tie into a fire alarm. That's standard equipment, that's per NFPA. You know, our fans have to shut off if there's a sprinkler system present, so we don't interrupt the distribution of the sprinkler system. So the standard controller is the one you see kind of top left. It says new digital touchpad remote. That's what comes standard with every fan. That's standard equipment if you don't specify anything different. That controller also has a different firmware on it where it can control up to 4 fans, but you have to specify it as so or order it as such. It'll control up to 4 fans. You can control 4 fans individually or together. And then there's another option for that controller 4 to have a temperature sensor on it. So it senses the temperature down low, and your fans will come on and speed up based on the settings that you set for that temperature. To the right of that is an analog controller. It's a NEMA 4X controller. It's really kind of for a harsh environment or a washdown environment. Very simple. Got a potentiometer and a selector switch. On the left, you've got forward, reverse, and then off and on. And of course, you've got a potentiometer to set your speed. The next option, we have a controller 30. You can control up to 30 fans. This controller has a lot of options. Control fans individually, group fans together, all fans at one time. We have timers that you can set for the on-off operation. And there's also passcode lockout for managers on the project. Also, this controller can be tied in what we call an air effect. We'll have a temperature sensor up top and down low, and it measures temperature and humidity in the fans and speed up and down to achieve 100% destratification. So a lot of options there. Next is the AirLink, and this is a building automation system integration unit. So if you want to tie into a building automation system, you need to specify the AirLink. It speaks the correct language of the current building automation system. And on top of this AirLink, we have what's called local override. Basically, it's a switch that if say a gym coach comes in at 8 o'clock that night and the building automation system has the fans off, this coach has no way to turn these fans on and off unless we have a local override. He can switch it to local and control the fans locally, but he has to cut it back off when he leaves practice to give it back to the building automation system. So some schools and gyms want this, and then we have the next option, which is dual control. So this is really cool. So the coach really doesn't have to switch it back over and give the control back to the building automation system. It takes the last known command, whether it's local or from the building automation system.
Great. Thanks, Jason. We're getting close to 15 minutes, so we'll try to breeze through this next segment. Yep. After working on various different projects with HVLS fans, I found that most of the coordination time spent is to figure out drop lengths to ensure that we have the proper clearance. Is there a simple rule of thumb while designing and installing these fans to make selecting a drop length a bit easier?
Definitely, and all information's on our website. We have spec sheets, installation manuals to keep, it'll help you with different pitches and how far to drop it down. I don't have that chart up now, but I want to say real quick, we also have an applications engineer on staff. If you have set of plans that you want to send us, get with Long, he'll lay these fans out for you and advise to stay away from walls. But real quick on these clearance guidelines, I know we're running out of time here. We need to be 3 times the diameter away from a wall. And I'm sorry, 1.5 times the diameter away from a wall and 3 times the diameter away from another fan. So as this air comes down, hits the floor, it's going to come back up the wall. Same thing with the 2 fans together. As it comes down, when the 2 air curtains hit each other, it comes back up. This causes turbulence, so we need to make sure we adhere to these clearances. And OSHA, the blades need to be 10 foot above finished floor. NFPA, we need to be 3 foot vertically below sprinkler heads and centered between the 4 sprinkler heads. We need to be 15% away from obstructions, and there's a minimum 3 foot above blades to ceiling so these fans can breathe. And I think that's all the time we have, guys. Thanks for joining.
Perfect.
Think of Macro Air when you think of HVLS fans.
Jason, thank you. I appreciate you taking the time to help us out with this presentation. I know that's a lot of info for everyone. If anyone has any questions, you can always go to macroairfans.com, but I encourage you to contact your Long sales representative for any questions, and we'll get those answered for you. Don't forget to join us next week. We got one of our hydronic superstars, Sean Davenport Smith, and he's going to talk about domestic hot water plumbing generation systems with Link by Watts. So we'll see you guys next week. Thanks again for joining, and enjoy your rest of your week and your weekend.